In this video, we'll explore 10 essential software design best practices that can be grasped in just 10 minutes. Modularity is about breaking down a complex system into smaller, manageable, and independent modules. When modularity is not followed, code becomes convoluted, challenging to maintain, and lacks the flexibility to adapt to changes. Embracing modularity leads to a more organized, reusable, and scalable code base, making development and maintenance more efficient. Here are things you can do to achieve modularity in your project. Divide your code into small, independent modules. Each module should have a well-defined responsibility or functionality. Promotes reusability and maintainability. Think about a banking application for a moment. Instead of cramming everything into one massive block of code that tries to handle account management, transactions, and authentication all at once, why not break it down into smaller, manageable parts? You could have an account manager that takes care of everything related to accounts, a transaction processor to handle the nitty-gritty of transactions, and an authentication service to manage logins and security. This way, each module focuses on its own specific task, making your code more organized and much easier to reuse down the line. Encapsulation is a fundamental concept in object-oriented programming that involves bundling the data, attributes, and methods, functions that operate on the data into a single unit known as a class. The key idea is to encapsulate or shield the internal details of an object from the outside world, allowing controlled access to the object's functionality. Access to the internal state of an object is typically restricted, and interactions with the object are facilitated through well-defined interfaces. Encapsulation promotes a more secure, maintainable, and understandable code base by restricting direct access to an object's internal state. Following encapsulation principles results in code that is easier to manage, update, and debug. Failure to encapsulate can lead to unpredictable behavior, increased dependencies, and difficulties in maintaining and evolving the software over time. Here are things you can do to achieve better encapsulation in your code. Encapsulate the internal details of a module, exposing only what's necessary. Use access modifiers to control visibility, e.g., public, private, protected. Reduces dependencies and isolates changes. Let's talk about the bank account class. Imagine a scenario where all its attributes like balance and account number, along with methods for actions like deposit and withdrawal, are open to anyone. That means external code could easily mess with these variables directly. Now here's where encapsulation comes in. By making these attributes private, we create a safeguard around them. Instead of just throwing the doors wide open, we provide specific methods to interact with the account. Take the withdraw method, for example. It would not only change the balance, but also run necessary checks to make sure everything is in order before any changes happen. This approach keeps the internal workings of a bank account safe and sound, ensuring that any interactions happen through well-defined, controlled methods. It's all about protecting the integrity of the account while still allowing users to perform necessary operations. Consistent naming conventions are a set of guidelines for naming variables, functions, classes, and other code entities in a uniform and standardized manner. Adopting consistent naming conventions across a code base enhances readability, maintainability, and collaboration among developers. These conventions define a common language for expressing the purpose and role of each code entity, making it easier for developers to understand and work with the code. Consider a scenario where you have a class representing a customer in an e-commerce application. With consistent naming conventions, attributes and methods related to the customer might follow a pattern, such as customer ID, customer name, and get customer details. Without consistent naming, you might encounter variations like cust ID, cust name, and fetch details for client. The former provides a clear, standardized approach, while the latter can lead to confusion and increased cognitive load for developers. Here are things you can do to achieve consistent naming in your project. Adopt a consistent naming convention for variables, functions, and classes. Enhances code readability and makes it easier for others to understand your code. Follow established naming conventions in the programming language or framework you're using. In short, consistent naming conventions are essential for creating maintainable, readable, and collaborative code. By establishing and adhering to a standard set of rules for naming code entities, development teams can foster a shared understanding of the code base, streamline collaboration, and enhance overall software quality. SOLID is an acronym representing a set of 5 design principles in object-oriented programming that aim to create more maintainable, scalable, and flexible software. These principles were introduced by Robert C. Martin in his classic book, Clean Code, and are considered foundational for building robust, object-oriented systems. These principles provide a guideline for designing flexible and modular systems that can evolve with changing requirements and are easier to understand and extend over time. Here are things you can do to implement the SOLID principle in your project. Learn and apply SOLID principles: single responsibility, open-closed, Liskov substitution, interface segregation, dependency inversion. Helps create more scalable, flexible, and maintainable software. Adhering to SOLID principles promotes the creation of high-quality, maintainable, and scalable software. DRI, or don't repeat yourself, is a software development principle that encourages the elimination of code duplication. The idea is to promote code reusability and maintainability by ensuring that a particular piece of knowledge, code, logic, or functionality is expressed in only one place in the codebase. DRI aims to reduce redundancy, improve consistency, and make the codebase more efficient. Imagine you have a web application where user information needs to be validated in multiple places during user registration, login, and profile updates. Without adhering to DRI, you might have similar validation logic duplicated in each of these scenarios. However, by applying DRI, you could create a centralized validation module or function that is reused across all these contexts. Any changes or updates to the validation rules can then be made in one place, ensuring consistency and minimizing the chance of errors due to inconsistent rules. Here are things you can do to achieve DRI in your project. Avoid duplicating code. Instead, create reusable functions or classes. Reduces the risk of bugs and makes code easier to maintain. In summary, DRI is a fundamental principle that promotes code efficiency, consistency, and maintainability. By eliminating redundancy and centralizing knowledge, developers create code that is easier to read, update, and extend, ultimately leading to more robust and sustainable software. Separation of concerns, SOC, is a software design principle that advocates for dividing a computer program into distinct and independent sections, each addressing a specific concern or aspect of functionality. The goal is to isolate different responsibilities and ensure that each component is focused on a single task, making the system more modular, maintainable, and comprehensible. Consider a web application that handles both user authentication and data retrieval from a database. Without separation of concerns, the code responsible for authentication and the code handling database queries might be tightly intertwined. However, by applying SOC, these concerns are separated into different modules. The authentication module handles user authentication logic, and the data retrieval module manages interactions with the database. This separation allows for easier maintenance, as changes in one concern do not affect the other. Here are things you can do to achieve better separation of concern in your software. Divide your code into distinct sections, each handling a specific concern. Improves code organization and makes it easier to understand and maintain. In summary, separation of concerns is a fundamental principle that contributes to the clarity, maintainability, and scalability of software. By isolating different concerns into distinct modules or components, developers can create systems that are easier to understand, modify, and extend, leading to more robust and adaptable software architectures. Error handling is a critical aspect of software development that involves managing and responding to unexpected situations or errors during the execution of a program. Proper error handling ensures that a software application can gracefully handle exceptions, providing meaningful feedback to users and preventing catastrophic failures. Effective error handling involves anticipating potential issues, identifying error points, and implementing strategies to manage and recover from errors. Imagine a web application that interacts with a database to retrieve user information. Without proper error handling, if the database connection fails or a query encounters an issue, the application might crash or display an obscure error message to the user. However, With robust error handling, the application could catch these exceptions, log the error details for debugging, and present a user-friendly message indicating that there's an issue with the database connectivity. Here are things you can do to achieve better error handling in your application. Implement proper error handling mechanisms to gracefully handle unexpected situations. Use try-catch blocks or similar constructs to handle exceptions. In summary, error handling is a fundamental aspect of software development that enhances the resilience, usability, and security of applications. Neglecting proper error handling can result in poor user experiences, security vulnerabilities, and difficulties in diagnosing and addressing issues. A robust error handling strategy is essential for creating reliable and user-friendly software. Comments and documentation are crucial elements in software development that enhance code comprehension, maintainability, and collaboration. Comments are annotations within the code that provide additional information, explanations, or context, while documentation refers to external descriptions of the code's purpose, structure, and usage. Both contribute to creating a comprehensive understanding of the software for developers, maintainers, and other stakeholders. Consider a complex algorithm that involves intricate logic for sorting an array in a specific way. Without comments and documentation, the code might be challenging for other developers to understand. In this case, you could use comments within the code to explain the purpose of each step, the rationale behind certain decisions, or any potential edge cases. Additionally, you could provide external documentation that outlines how to use the sorting algorithm, its time complexity, and any performance considerations. Here are things you can do to achieve better documentation in your project. Add meaningful comments to explain complex parts of your code. Write clear and concise documentation for your codebase. Helps others understand your code and accelerates onboarding. In conclusion, comments and documentation play a crucial role in ensuring the maintainability, readability, and collaborative nature of a codebase. While well-written code is essential, supplementing it with comments and documentation creates a more holistic and accessible resource for developers and stakeholders. Test-driven development, TDD, is a software development approach where tests are written before the actual code implementation. The TDD cycle typically involves 3 steps: writing a failing test, writing the minimum amount of code to make the test pass, and then refactoring the code while ensuring the tests still pass. TDD emphasizes the creation of reliable, maintainable code through the continuous and automated testing of software units. Suppose you are tasked with developing a function that calculates the factorial of a given number. In TDD, you would start by writing a test that specifies the expected behavior of this function. The initial test might assert that the factorial of 5 is equal to 120. This test would fail initially because you haven't implemented the factorial function yet. Next, you would write the minimum amount of code necessary to make the test pass. In this case, you would implement the factorial function to correctly calculate the factorial of a given number. Once the test passes, you might write additional tests for edge cases, such as the factorial of 0 or 1, and repeat the cycle. Here are things you can do to follow test-driven development in your software development. Write tests before writing the actual code. Ensures that your code meets the specified requirements and is easier to refactor. In summary, test-driven development is a methodology that promotes a rigorous and systematic approach to software development. By writing tests first, developers create a safety net for their code, leading to improved reliability, maintainability, and confidence in the software's correctness. Performance considerations are essential in software design to ensure that applications operate efficiently and meet user expectations. By making informed choices in algorithm selection, data structure design, and resource management, developers can create software that performs well, even under demanding conditions. Optimization efforts can lead to faster response times, improved scalability, and an overall enhanced user experience. Here are things you can do to improve the performance of your software. Be mindful of performance implications when designing your software. Choose appropriate data structures and algorithms. Regularly profile and optimize critical sections of your code. That's all, guys and friends. In just 10 minutes, developers can familiarize themselves with these fundamental software design best practices. While software design is a vast and evolving field, adopting these practices will set the foundation for writing clean, maintainable, and scalable code. As developers gain more experience, they can delve deeper into advanced design concepts, but mastering these basics is crucial for building robust and efficient software solutions. This video is inspired by an article from Lazy to Read on the dev.to website. If you want to dive deeper and explore the original piece, just scan the QR code to access it and discover more insights and useful links.